Garrett, welcome to the Mr. Beacon podcast. It's really great to have you on the show.
Thank you for having me. It's a pleasure to be on the show.
Well, in many ways, this is a sequel. We had your co-founder, Misha, the CEO of Nodle, on back in February of 2019. Seems like just forever ago. So if anyone wants to compare and contrast, they can go back and watch that. But let's save them the trouble. Why don't you just give us a quick recap on what your company does? And you know, I'm interested in the progress. We will visit that theme. You know, lessons learned, where you've got to, where you're going to, but also you have some intriguing information about what I would see as an ambient IoT device, your nano computer, the N1 device, and I want to talk about that as well. But for people that didn't watch Mr. Beacon back in 2019, can you remind them what your company does and how do you describe it now?
Sure. So we're Nodle. We like to say that we're connecting the real world with the digital world. And we started back in 2017 using smartphones and Bluetooth to build wireless networks. So since we started it, these ideas have become very popular with things like Apple AirTag, where you use a swarm of smartphones to connect things like a little Bluetooth tag to find your keys or your pet. But we're much more interested in the enterprise world. So last year, Apple made over $1 billion just on AirTag, just for finding your car keys. We believe that the enterprise space is much, much bigger. And we believe one of the key kind of limitations to seeing just a swarm of Bluetooth devices in the real world around us is a common network where a Wiliot tag can talk to a network, where an iBeacon, where a air conditioner can all work with the same network, much like the internet, and communicate with each other. And that's really what we're building, is we're working to create a standard network where, starting with smartphones, can communicate with the world around us, capture Bluetooth signals, and then pass those signals back to the owner of that device.
Amazing. I believe in that world too. How are things progressing? How big is the network these days?
So it's been very exciting. A few things have happened since 2019. It's definitely been a wild ride, but it's really interesting. We've proven out the fact that you can build enterprise revenues with a network like this. So our largest customer now, an insurance company in France, is using our network to locate stolen vehicles. And it's working. We'll probably have some announcements more on that in the next few months. But we've shown that you can use Bluetooth just like you've used a cellular or a satellite connected device. And fundamentally, we believe this is incredibly transformative, because not only can a lot of devices today that are using a SIM card just use Bluetooth, but a lot of devices that today just could not afford to connect to the internet can now connect to the internet. We're talking, in some cases, an order of magnitude more cost-effective and more power-effective way to send data up to the internet. So we've proven this out with some insurance customers. We're working now to scale this up and enable all kinds of other devices. One of the key trends with our network is its programmability. And we announced at the beginning of this year a white paper, and we're now pretty deep into the development and deployment of the programmability of this network with something called smart missions. And a smart mission basically is we can program our network to any specific Bluetooth device that we wish. If Wiliot wants to use the network, we can program its identifier into our network, and now our network adapts to it and can communicate with that device based on programmability of the network. We think this is really cool because today all these Bluetooth networks that are deployed are not programmable. If you want to use a competitive network, you have to use their language, their firmware, and it's incredibly cost prohibitive.
Gosh, so much to unpack there, and I want to go back and unpack it. But just back to the question on size. So I guess and maybe you don't want to answer that. That's fine if you don't. But the way I think about these networks is in two dimensions. One is the things that you're tracking, kind of the tags, and then the things that you're using to read, which I guess is the real network, is the how many devices do you have that have the Nodle app or the SDK? Are your readers all in the Nodle app, and how many of them are there? I guess that's two questions, but pick which one is it.
So right now it's in the hundreds of thousands of active devices.
Yes.
Obviously, we want to increase this much more, but even that's enough to start covering places like Europe, especially France. We've had a big focus on France with reliable coverage. And just a few weeks ago, we came out with our Explorer map. So if you type in network.nodle.com, Nodle.com, so network.nodle.com, you can see this incredible map of the world around us. And you can actually see, you can zoom in onto your neighborhood, and you can see within 30 days, did a smartphone running the Nodle software come into your neighborhood? And you can start to explore the map yourself, which we think is really, really cool. We grow through a few ways. So one is the Nodle app. So regular people, just like you and me, can download the Nodle app. I think you've been playing with it for some time. And it allows your smartphone just to start earning cryptocurrency, because we are a crypto incentivized network for sharing your Bluetooth. So we operate through an app. We also have an SDK, and this SDK can go into games and other mobile apps. And this provides a way for developers to earn crypto just by sharing Bluetooth anonymously. So it's a multi-pronged way of growth. And we're also having discussions with smartphone makers and telcos and OS providers to embed this at a native scale. Our long-term goal would be to really be the common network that things like Apple's network and Google's network could use to talk to each other. Because you don't have to trust one single company, you have this decentralized aspect of the network. And we think that's really important. And a lot of customers think that's really important.
So it's your app, but it could be a lot more than that. It could be an SDK that goes into other things. Well, what about things like Wi-Fi access points? Could you put your SDK in there as well?
Yes, definitely. We have a partnership with Cisco Meraki. So we actually work with some of their APIs for enterprise settings. And we've been looking very closely at gateways. So being able to support, right now, Android, kind of Linux Android gateways, but even a single tiny Bluetooth chip with an internet connection. This is something else that we've been looking at as well, so that you could build a gateway for almost nothing.
So if I was the CTO at Starbucks and I happened to be a Cisco Meraki customer, I could potentially, would I have the ability to activate the Nodle network at every Starbucks? So if someone lost a device and it ended up in a Starbucks, then that could kind of report it back somehow.
Yes, it would be very straightforward to do that. We think that use cases more like analytics are much more interesting. So strangely enough, we see a lot of coffee makers on our network. I think because some brand of coffee machine is just blasting Bluetooth, probably a bit more than they should, but it's one that actually shows up on our network quite a bit. And if that was transmitting analytics, now Starbucks could get essentially real-time analytics from their coffee machines. How many coffees are being made? What type? Is the motor okay? What's the status? And it's these little analytics, this type of information that it can really help a business and really increase efficiencies.
So you have a network, and it sounds like you can already, across the hundreds of thousands of nodes in that network, look at the kind of Bluetooth devices that are out there, and you kind of get a sense of what's going on.
Yeah,
that's pretty cool.
We can run searches. We call it kind of a search engine of the physical world. And what's happening with our transfer of smart missions is this data will actually be routed at the edge. So this means that if we want to route data directly to a customer server without it having to go through Nodle, then we can do so.
And let's get back to the use case of finding stolen vehicles. So the vehicles do they have a special Bluetooth tag in there, or are you just using the fact that cars have a lot of Bluetooth devices in them anyway?
They have a special Bluetooth tag, which basically transmits a unique identifier. In this case, they've custom designed it, but you could use any off-the-shelf Bluetooth tag. It just depends really on your level of security. Most cars do transmit Bluetooth, like every Tesla transmits Bluetooth, but most of these companies are pretty clever and anonymize the identifiers. So you can't locate a specific vehicle.
Okay.
But if a car company, we see a lot of Harman, so Samsung owns Harman, sound systems out there in the wild. If they wanted to include a unique identifier in their transmission, we could very simply program that into our network and be able to recover stolen vehicles made by that radio company.
And this is getting geeky, but do you just see Bluetooth low energy advertising packets, or do you see other kind of Bluetooth devices, audio devices that are looking for a connection?
Right now, it's just what you see in a scan. So advertising packets is what we focus on.
Okay. Yeah.
We can technically support anything that the phone supports. So in the future, Wi-Fi, we're very interested in what's happening with some of the new Wi-Fi standards for building networks. Ultra wideband. We think it would be cool if phones could do mesh networks in the future. There were even some experiments with LTE Direct in the past before the telcos killed that off. So really, we make smartphones programmable in new ways, new, very secure, privacy-preserving ways. And any new protocol that's added to the phones, we can support that.
And to what degree, you talked about things being killed off. It feels like Apple and maybe others are trying to kill off the crowdsourcing use case with Bluetooth. Are you able to do what you do on Apple phones, or is it an Android only thing?
Yes, we can do iOS and Android. These certain companies want to make it very difficult. They claim in the name of privacy, but when they're making $1 billion on a certain product and their privacy changes, build a wall around their $1 billion product, it's a tough argument sometimes.
Yeah.
Thankfully, especially with the new European regulations, these things have to be more open. Android's really great about this. Apple is definitely moving in that direction. So today we work both on iOS and Android pretty reliably. Android, you can do a bit more. Android, you can have a bit more fun with, but both Android and iOS work quite well. And a lot of people have built their businesses around both phones, so the manufacturers really have to make sure and maintain these things. I'm sure you guys at Wiliot, you're really pushing the limits of what a smartphone can do. Even using smartphones to energize your network of tags. So I don't think anyone's really thought of using a phone as a wireless energy communication device, but I think that's pretty awesome, and definitely pushing the limits of what the Play Store would like.
So that's good to hear that you have that coverage on both ecosystems. And I think you implied it, but let's just make sure it's super clear. There's a motivation for consumers to install the app. Why would I install the Nodle app? I mean, I installed it because I thought it was cool and super interesting. But why might someone join the network?
So right now it's because they can earn a bit of crypto. Today it's not much, but we believe someday that it could help pay for a fraction of your data plan. So really it's a crypto economic model, which means you get paid in cryptocurrency for sharing a bit of your Bluetooth. And we think that this is really what's required for networks like what Apple and Google are doing with these small tags to scale into the enterprise. People need a robust and reliable network, but they also need a network that can be incentivized to grow in specific parts of the world where today there's not much coverage.
And obviously, since we last spoke, crypto has been on a roller coaster ride as far as positivity and negativity. How has that impacted you, if at all? in the way you describe what you do and people's willingness to use it?
It's kind of crazy because when I first met Misha back in 2014, 2015, crypto wasn't really a thing. We were always steadfast on building these new types of mesh networks. And there was like the Bitcoiners was kind of a movement. There were the mesh guys, the decentralized mesh networking guys. And then there were kind of the anarchists, the people working at BitTorrent and torrenting files and all this type of stuff. And it wasn't really until much later that the crypto space came around. And Misha and I had always been very, very focused on how do we build enterprise applications that work. So since 2017, even when crypto came into the field, we realized that crypto was a very good way to structure these networks and to secure them, just from a fundamental decentralized root of trust. I can say definitely having crypto boom and then crash and then boom and then crash. It's a bit wild, but we've always been focused on how do we provide a great enterprise product that works, and scaling that up in that fashion.
And what are the benefits that blockchain and crypto provide to the solution that you're building?
So, like the internet, it's a decentralized system. And we believe that any type of network that's operating at the scale like Nodle, it has to be decentralized, which means that data isn't going through one server. And this is also something that a lot of customers, enterprise customers, have demanded. They say, no, we want a system that can work on our own servers or route data directly to our own servers. And a decentralized system is ultimately the best way to do that. Now, you need a way to secure that, but also to incentivize that system. And that's when a cryptocurrency comes into place. It would be like building in a global telco billing system into the fundamentals of the internet. Back in the 90s, they weren't thinking like that, and cryptocurrency didn't exist. But now it does. We have these tools, and we can program bandwidth incentives. We can program all these things into our network, which can work at a fundamental IoT level, which is really cool.
Very good. Okay, let's talk a bit about the hardware. Before we do that, I just want to say a couple of things about how I see what you do, which is, there are many terms that are used to describe it, but I really see your company as being an ambient IoT company. This podcast is now called the Mr. Beacon Ambient IoT Podcast, and it's so maybe I'm just sort of justifying why you're on here, why I thought it was a good idea to have an update. But I really think you're ambient because ambient is about connecting every single thing to and having readers that are ubiquitous, that are everywhere, and that feels like what you're doing. That yes, you can track cars, but you could equally track coffee makers or pairs of socks or anything, and the network could be very broad and heterogeneous. So, would you kind of accept that as a marketplace that you're in?
Yeah, I'll take it.
Very good.
The way that we've been thinking about it is that Wiliot's probably one of the best examples of an enterprise company that's built a really cool application on top of Bluetooth. But we fundamentally believe that what's keeping these types of things, these Bluetooth tags, these Bluetooth devices from just becoming a multi-billion-dollar, multi-trillion-dollar space is the lack of a network. If you want to go connect your device to a network, you've got to modify all your firmware, change your business model, build a hardware device, connect it to a network, and then all that data has to go through sometimes a competitor, and it's just it's not productive. And so we believe that the difficulties in really getting online, it looks a lot like the internet did in the 90s, where if you want to get online, you've got to get a CD, pop it in your computer, plug your computer into a telephone line, and hope and pray that it works. And it wasn't really that conducive until the 2000s, when internet connectivity spread. It really became standardized, and there was one common network for computers and humans and machines to talk to. We think the same thing should be for Bluetooth devices. And so we believe the network was missing. We started to build out the network. But now, what can we do with this network? Most of the world is thinking about Bluetooth iBeacons, simple Bluetooth device that says, hello, I'm here, here's my name. But I thought that wasn't that exciting. I said, what is this going to look like in 100 years from now? And what we imagined was a device that could use the full capabilities of the nodal network and be as intelligent as possible. We look at Wiliot devices, we say, that's cool, but what would happen if you crammed as much compute power into a device like this as possible? What would you get? And then what could you do with such things? So that's kind of how the nodal nanocomputer was born, by saying, how can we leverage the full capabilities of a network like Nodle to the extreme, and then set up a world where in 10 years from now, they're not just talking over Bluetooth, but maybe they're building mesh networks with a different technology like Wi-Fi. Maybe they're actually becoming part of the internet infrastructure itself, doing compute, building basic wireless networks, and so forth.
I love it. So the first product is called N1, is that right?
Yeah. The N1 is, think of it like a prototype, an open source prototype, just to set the space, to get people thinking about where this goes next. This was kind of our first foray into printed zinc-based battery chemistries, which is a totally new space that's still evolving very quickly. But this is cool because you're not using lithium, which has a much higher carbon impact. So we can build this type of ambient computing, essentially a zinc battery with a system on a chip, and we can put much more capabilities into it. So the nanocomputer is loaded with sensors, temperature, humidity, pressure, motion, a hardware security module so we can encrypt communications. And it's really just the first step into where we think things are going to go next.
And it can it listen as well as transmit, or does it just transmit?
Today, the firmware that we've open sourced is just transmitting. What we're doing with smart missions is we're programming logic that we can push into the network. And so we want to use the nanocomputer as a reference device for smart missions. So this means that we can build a simple program that is deployed on the network. And we think that just a network running applications is kind of an interesting idea. Having a wireless network that's programmable. And then we can have that network interact with a device like the nanocomputer in a programmable fashion. And so that's really where we see things heading next, is that we open up this type of this device for other developers so that they can program things that run on the nanocomputer. They could build an app that runs on the nanocomputer and captures sensor data over the course of a week and then computes on top of it, or so forth. And so that way enterprises can really get to the edge. They can start programming applications at the edge, and they have a common network that can send data back to the cloud.
Let's describe what this looks like and roughly how much does it cost? So
today the nanocomputer is a sticker. It's about 4 inches by 3 inches, so it's a relatively small sticker. The target cost is $5, below $5. But today at low volumes, it's a bit more expensive. It's closer to $10. The goal for this, though, is to create a path towards sub-dollar computing. And today, you're never going to do that with the standard way we manufacture products. Today, it's you have a circuit board, a PCB, a battery connected together. You put it in a plastic case. That's how most things today are manufactured. You have all these different components, you stick them together. We think that if you can continuously manufacture, like tape or a newspaper, a product like the nanocomputer, then you can get the economies of scale that we need. We're still several years away from this. And again, we believe that this network is missing that can allow the economies of scale and the prices to come down. That can enable a device like the nanocomputer to be much, much cheaper than existing hardware manufacturing. But there's several years to go, and there's kind of a long manufacturing scale up, and it's really a shift of supply chain. When the LED came out in the 80s, it was a very expensive device. Everyone was using light bulbs, and LEDs were extremely, extremely expensive. And it took this type of device to come out to get that product market fit for the price of an LED to just collapse exponentially. And now you've got billions of LEDs in displays. So we think that we can do the same thing with computing if we start thinking about computing from a printed standpoint. And
today, there's a printed circuit board, and there's a zinc battery. And it's rechargeable, right? So it has potentially.
It's a rechargeable battery chemistry. I'm a big believer in photovoltaics, so solar panels. And we think that a lot can be done to kind of unify the design into one common substrate. So we don't have a separate battery, a separate device. We can actually print everything together. And if you look at what's happening with a lot of new technologies, circuit boards printed, even chips are printed today, especially some of the new technologies coming out of China, where they're really integrating printed boards with silicon chips, with printed batteries. We think there's really a big space to innovate on what it even looks like to build a computer. So we like to think about, could this be something like a Raspberry Pi, but what comes next? How do we build the next level of computing for developers that can be just built at really, really high volume?
And what is the process to do the programming? Can it be reprogrammed over the air, or is it a matter of connecting to the tag with some kind of device?
Right now, it's like a JTAG interface.
Okay.
It'll probably remain like that for some time until we can open up an over-the-air programming function. That would actually be a cool smart mission to see if we could make a smart mission on our network that would allow you to program the device. So it's very early today, but it's really just to get people thinking about this new type of computing. And if you make it completely open, force as much compute power into the device as possible, what type of applications will people come up with?
And what's the status of the project?
So right now, phase 1 is open source. So you can check it out on GitHub. You can see, you can test it out. Right now, we're using it just really as a development platform for experimenting with new beacon frameworks and things like that. And we're now thinking a lot about a V2 design. So I can't say anything yet, but we think there's really a lot of room to innovate and make something really streamlined, really powerful, really aware. I mean, really, ambient computing should be intelligent. It should be loaded with sensors, as smart as possible, and ultimately be able to be made as cheap as possible too. If we can see volume someday in the millions or hundreds of millions of units.
For sure. And I'm always conflicted with this show because obviously I have a day job. It is at Wiliot. You've mentioned Wiliot. I've been studiously trying not to talk about Wiliot, but I think people may be curious, and we can cut this bit out because I really want this to be about Nodle. But I was thinking, I was just sort of going through and seeing, well, how does this compare with what Wiliot is doing? And I know that some people at Wiliot think, why the heck is Steve interviewing these other people that are doing ambient computing? But I really believe what we're doing is building a category, and that there will be multiple products, each one with its own strengths and weaknesses. It's like, this is about having a toolkit, not every problem does not require a hammer. You need hammers, screwdrivers, the whole plethora of things. And what Wiliot does, our primary focus is battery free, and the price point that we're focused on is sub 10 cents. So when we started, we were like, we used to say, it's less than $1. Now we're like, so next year, 2024, it'll be less than 10 cents. And I'm hoping that we can really hammer that down. We're looking at stripping out the paper in the paper tag and just printing the antennas directly on cardboard and stuff like that. But
Wow.
you obviously give things up there. There's no way that's going to be ever going to be programmable. It's we burn the firmware in at the chip
Yeah.
manufacturing level, and we have production runs of millions of these things,
Yeah.
not small numbers. And that definitely, and that there, we worked with a partner, Identiv, and so there is a zinc battery
Okay.
version of our product. But again, it's the same chip, so it's not going to do the kind of general purpose programmable things that you guys do, and it's not
Yeah.
rechargeable. The price point is definitely more than 10 cents for the zinc battery version, and so that's sort of, I would say, sits in between what you've described as the N1 and what we have for our general battery-free products. But I think, we need to have all of these products out there so that all the use cases can be built out and deployed, and people can learn. But whatever the tag, you still need the network, which is what you guys are really focused on. And so I think what you do and what Wiliot does is very complementary from that perspective.
Yeah, I mean, we're fundamentally a network. We want to be a network, and the nanocomputer was kind of built out of like this nagging angst of I said, why somebody needs to build a device that is hyper intelligent, can do everything. And if you're trying to build something for an enterprise that works today, and you're trying to be sensible, Wiliot is very sensible. Wiliot is a device designed to be as efficient as possible, deployed very quickly into production. What we were thinking of was, what does the anti-Wiliot look like? What if you take a similar form factor and load it with compute power, load it with an AI and sensors and mesh networking, and today it obviously is a very simple chipset. But what happens in a few years when you can have an AI chip that costs a few dollars and can run off of a few milliwatts? There should be a form factor ready to accept these new types of technologies. And so that's kind of where we're thinking of. You have the Wiliot, you have RFID at the bottom, and NFC. You've got the Wiliot battery free tag, which I think is an awesome form factor. You have the Wiliot battery powered tag, which obviously with a higher power budget, you can do much more. You can do more functions. You can operate much more often. And then way on the other side, you have like the Raspberry Pi, this like supercomputer. We're thinking of kind of what comes just before the Raspberry Pi. How can we take something like a Raspberry Pi, make it much, much cheaper, significantly cheaper, and then open source it to the world? What if you can make a device like a Raspberry Pi that costs a few dollars? What happens then? I don't know, but we want to open source it and find out.
I love it. I love the approach. So we should probably wrap up soon, but I want to make sure we've done justice for the use cases. You folks have probably learned a lot over the last few years. I can't wait to hear more about the car tracking. Any other use cases that, where do you see the sweet spots for what you're doing?
So obviously logistics. I think any use case where Wiliot is used today in more wide area sense. So things like shipping containers, shipping pallets, boxes and carts. Anytime we have to be tracking and understanding complex logistical networks, networks like Nodle help you get that visibility. And we believe that devices like Wiliot are some of the best tags and some of the best hardware to do so. So we think there's a fantastic combination there. I'm very interested in things like insurance, so tagging construction equipment, generators, stuff that needs to run. A Bluetooth tag needs to run for 5 or 10 years, and a lot of the time these devices just disappear into the wild. So how do you have a connected asset that can stay connected for 10 years, can end up in really wild parts of the world in the middle of nowhere and still be able to be connected? Even if it takes a few days for our network to find it, in the woods or in the forest somewhere, somebody walks by with a cell phone and it gets picked up. And that's incredibly valuable for insurance companies, for logistics networks that have assets all over the world. That's really what we've been looking at right now. really helping companies like Wiliot or other Bluetooth tag manufacturers or device manufacturers bring their devices online.
Well, let's talk about those other tag manufacturers. This podcast started, I finished writing the Bluetooth Beacon book, The Hitchhiker's Guide to the Beacon System was the subtitle. And the podcast came out of just wanting to carry on talking to smart people that were developing cool beacon technology and the networks that were using that. Even back in the book, there's a chapter on the networks, although that was pre-Nodle. Nodle. But you probably have one of the best perspectives of the Bluetooth beacon market because your network is connecting on there. And I think there's been a shakeout, but there's still a lot of some of the early players have disappeared, but you still got your contact IOs, the Estimotes. There's oh gosh, so many, so many. The Chinese vendors, there's some really interesting players there. What's interesting there, and what beacons are you using when someone wants a Bluetooth beacon? What do you recommend, and what are you seeing out there?
So we've tested all kinds. The biggest thing for us is that because our network's global, we find that a lot of beacon manufacturers are a little lazy and they'll reuse IDs, like especially if you look at the really low cost chipsets. So we'll query our network for it and we'll see 5 of them in different parts of the world. And so we found that somebody that has a good quality chipset, but also can put the identifier on the device, so you have it laser etched or something on the hardware, is also kind of difficult. If you go and buy a bulk beacons from manufacturers, a lot of times they don't have an easy way to identify it. And this was also why we had to make our network programmable, because even within the beacon world, there's kind of 10 different sub-formats. People don't always follow the spec properly. The way that they identify devices is all totally different. Some people use major minor, some people use MAC ID, which most smartphones can't even see anymore. So it's very diverse. What we like, we've got a great relationship with EM out of Switzerland. So this is the same group that's making your luxury Omegas and your Swatch watches is making Bluetooth chipsets, because they had to start during the quartz crisis. They got really good at building low power chipsets for timing and things like that. And so EM is doing it's just good, reliable Bluetooth device that you can scan with your phone and they work. Minu is just kind of dominating the space in Asia. They're really doing a good stuff. Obviously, you want to have a diverse supply chain, so it's great to have a supplier in Europe, a supplier in Asia. And if anyone else has Bluetooth devices, reach out to me. I'd love to chat. I always want to test stuff. And of course, what you guys are doing is really cool. I think in the next 2 or 3 years, the Wiliot, especially the battery powered tags, I think can be really interesting for enterprise as well. I'm just kind of antsy, and I want to see a full ARM chip and sensors and a hardware security module and all the features. And I want it to run for 10 years and communicate to my network and build mesh networks and talk to satellites and stuff. So that's why we were thinking about building our own device. What would it look like? Kind of the ultimate stair.
Yeah, I think there's plenty of room. The issue is growing the category, not fighting for market share. So I love the fact that you guys are doing what you're doing. Garrett, thanks very much for telling us about it. Well, you've got proper music headgear on. That makes me think that you're an audiophile. Are you an audiophile? Do you like music?
I do love music. I used to actually wear studio monitors, so the ones that would actually plug into the mixing panels. But I definitely love music. Was very inspired by the iPod. That was certainly one of the more pieces of hardware that got me really inspired as a child. And
you did a TEDx presentation that had music as the theme. I was just watching it before this, and I was struck by the parallels with Nodle and some of the concepts that you were talking about.
Yeah.
That's pretty cool that you got. How do you get to do a TEDx? What's the secret?
So it was the local TEDx in my hometown, and I don't remember how, maybe through my school. I think I was in high school when I did that, but had already been really thinking about mesh networks and how to think about connectivity. And I really thought it'd be getting music to play with devices that would bring these types of new networks. In fact, it's more like Bluetooth devices, which we'll probably talk about in a second, which are more likely to do so. So
very good. So back to music. Did you choose 3 songs that are important to you? Did you manage to do that?
So I had 3 that were kind of very special. So the first was Viva La Vida by Coldplay. And it was more for the advertisements. I remember sitting on TV when I was very young, watching the Apple ads.
Oh.
These were done by TBWA Chiat Day in Los Angeles. And some of the most amazing animation I'd ever seen. I said, wow, I want to make stuff like that. And that's what got me becoming a graphic designer, was that ad playing Viva La Vida. Back in the old days when Apple was doing really, really cutting edge stuff and pushing the limits.
They did amazing ads, didn't they?
Yeah.
I think back to the Mac versus PC ads. Didn't have the same graphic flair, but certainly incredible creativity.
A lot of what's taught me is just looking at things in the world around us and saying, how is that made? And first was really that ad. I said, how do they make that ad? And that got me learning about graphic design. And then I said, let's take what I've learned in the second dimension and push it to the third dimension. And that's how I got interested in hardware. So back to music. The other 2 songs, which I really love, are a song called Stay Crunchy by Ronald Jenkins. He's this guy who just does really crazy keyboard. And then finally was the entire album of Random Album Title by Deadmau5. That's the album that got me into electronic music.
Mm-hmm.
I'd kind of been all over the place, and Deadmau5 is really cool because he does a lot of work with analog synthesizers. So for somebody like myself doing a lot of work in RF, people that take that same technology and they're making music out of it, to me is really cool. So Deadmau5, Ronald Jenkins, and Coldplay.
I love the way you're joining all these dots. You have a very integrated view of the world. How did you get to be doing what you're doing? You're co-founder of Nodle, and I can tell that from that TEDx talk that you'd been thinking about related concepts.
Yeah.
How did you and Misha meet, and what's your origin story?
I'd always been interested in mesh networks. So this idea that you can use the devices you already have, your phones or a specific node on your rooftop, to build networks. And Google in early 2010s, I would say 2012 or 2013, came out with the idea of the modular smartphone. Again, this was the early 2000s, where companies were really innovating and didn't have so much focus on profits, but more just on creating really compelling ideas. And Google invented and built this modular smartphone. So you could remove the screen, you could change out the CPU, and it was just almost like Lego blocks.
I remember it.
Yeah. And the crazy part is they had it working, but their finance team killed it off. So really, if that had gone through, we would be in a totally different world of computing. Computing would look very different than it is today. So that's what got me out to Silicon Valley and to a conference for Project Ara at the Computer History Museum. And it was there that I was introduced to Misha. I met some guy who was very interested in mesh networking. He says, you need to talk to this Misha guy from Europe. You guys are both on the same wavelength. I gave Misha a call literally in the second floor of the Computer History Museum, right above where they had the Babbage engine, this hand-cranked computer. And Misha said, "Oh my gosh, you're hired for an internship." And so that's at 17, I flew out to San Francisco and really never looked back, and started working with Misha, who today is my co-founder.
Incredible. So how long was it from that first internship and starting the company?
So the first internship, this was 2014 or 2015, and this was a different company called FireChat. So I had believed it would be music that would create these mesh networks for people. Their philosophy was it would be messaging. And so this was an attempt to create mesh networks, but allowing people to share messages. And FireChat was pretty exciting because it became really a symbol of democracy. So in all these protests around the world, this was really the tail end of the Arab Spring movement. People were using FireChat. It was actually kind of crazy because in the data, we would say, "Oh my gosh, there's a spike in this country. What's happening?" A few hours later on the BBC, we'd see coming through that there was a protest or some government had fallen or something crazy had happened. So it was really an interesting time, especially a kind of a wild first job in tech. So that was really the first job. And it was really it was total about 4 years until we came back together and started Nodle. In between, I had moved to India and lived in India for 2 years and came back in 2017 when none of these ideas really to build a very solid, sustainable mesh worked. We came back, said, let's give this another crack. Maybe we can use the concept of IoT devices, these little Bluetooth devices all in the world around us, to subsidize and incentivize the creation of these new types of wireless networks.
Very good. Well, Garrett, it's been great talking to you. I'm glad I got to hear a bit of the inside to how the company got started, and I love those music suggestions. You're going to have to send us the links. We'll publish the YouTube pointers so that people can listen to the music. Thanks so much for coming on the podcast.
Thank you for having me, Steve.
Thanks for watching this episode of the Mr. Beacon Ambient IoT podcast here on YouTube. You can listen to this episode on iTunes, Spotify, or wherever you get your podcasts. If you enjoyed it, please like and share this video. And be sure to subscribe for more videos. For more information about Wiliot, Ambient IoT, and IoT Pixels, head over to wiliot.com.